Hi there, everybody. I'm Mr. Lineberger, and today we're going to do some pretty amazing math. You're going to help me solve a problem. But first, a little music. Maybe you don't think of the ukulele as a rock and roll instrument, but you probably never heard one like this before. Woo! See, my band just had this giant banner made to go behind us on stage. When we're not playing, we want to hang it in our practice room. See that big wall back there? That's where we want to hang it. The thing is, I don't know how tall the room is. So, I'm going to need to do some math to figure out whether I can hang the banner. But first, let's start with something easier. Just a quick review. You all know what a rectangular prism is, right? In this case, I have a prism that is 4 meters wide, by 5 meters high, by 2 meters deep. If I want to find the volume of this prism, in other words, how much it can contain if we're filled with something like air or whipped cream or strawberry syrup, I would multiply the length and the width and then multiply that product by the height. In this case, we can represent this as an equation. Volume, we'll call that V, is equal to length, that's 2 meters in this case, times width, that's 4 meters in this case, times height, 5 meters. So, 2 multiplied by 4 is 8. 8 multiplied by 5, that's 40. 40 cubic meters would be the volume. Here's another way to think of it. Imagine that the whole prism is filled with cubes. Cubic meters. The bottom row would be the length times the width, 8 cubes. And I'd have 5 layers of cubes to get to the top of the rectangular prism. 5 times 8, that's 40 cubes. 40 cubic meters? Slick, right? Let's take things to the next level. What if we only know part of the information? Check out this rectangular prism. Imagine that we don't know the height, length, or width of the prism. Maybe all we know is the total volume and, let's say, the area of one side. Let's imagine that the total volume of this is 36 cubic meters. We also know that the area of the bottom of the prism is 12 square meters. How can we determine the height of the figure? Can we? You bet we can. When we look at our volume equation, V equals L times W times H. In other words, volume equals length times width times height. There's another way we could write that. Length times width, that's the same as area. If we have a rectangle, we determine the area by multiplying the two sides of the rectangle. So, instead of volume equals length times width times height, we could think of the volume equation as volume equals area of a side times height. Now, let's tackle our sample problem. We know the area of one side is 12 square meters, and we know the total volume is 36 cubic meters. V is 36. So, 36 equals area of one side, 12, times height. 36 equals 12 times H. How many 12s does it take to make 36? 2 12s is 24. So one more is 36. Our answer is 3. The height in this sample problem is 3 meters. Let's do one more sample problem, just to be sure you've gotten the hang of things. Imagine we have a rectangular prism with a total volume of 70 cubic meters. We know the prism is 5 meters long and 7 meters wide, but we don't know the height. We can still figure that out because we know volume equals the area of a side times the height. In this case, the volume is 70 and the area of a side is 35 square meters. 7 meters times 5 meters equals an area of 35 square meters. What can we multiply by 35 to get our volume of 70? 2. 35 times 2 equals 70. So the height of our prism must be 2 meters. Are you feeling more confident about this type of problem? Let's do one more before we figure out if I can hang my sweet banner in my band's practice space. Picture in your mind a beautiful rectangular prism. This gorgeous prism is on the tall side, we'll say 2 meters, and has long, luxurious hair. Right, hey, math, right. So, a prism 2 meters tall, and the area of the front of the prism is 8 meters squared. We know that the volume of the prism is 40 cubic meters. How long is the prism? In this case, if you look at my cool virtual diagram, we can see that we actually know the height, which was the thing we needed to know the last time. Height is 2 meters here. We don't know the width or the length, but we do know the area of one side, 8 meters squared. Volume equals length times width times height. We rewrote that earlier as volume equals area of one side times height. But depending on which way you orient the prism, any side could be the height. See? For this problem, volume equals the area of one side times length. Let's write that as volume equals 8 times length. The volume is 40, so 40 equals 8 times L. How many 8s are in 40? I could count by 8. That'll help me figure it out. 8, 16, 24, 32, 40. 5. The length of our gorgeous tall mystery prism is 5 meters. I think you're ready to help me with my banner. I don't have a tape measure to do the actual measuring, but I know the area of my band's practice floor because I bought a rug to cover it. The floor is exactly 40 meters squared. That means the room might be 8 meters by 5 meters, or 10 meters by 4 meters. It might even be 2 meters wide by 20 meters long. No, that's silly. It's a room, not a hallway. But it doesn't matter what the dimensions are. If we know the area, we can figure out how tall the room is. I also know the volume of my practice room is 120 cubic meters. So you might think it's crazy that I know that, but I'll just say an underwater music video was involved. The banner I want to hang is 2.5 meters tall. Is the room tall enough to hang it? I'll wait a moment. I know some of you are about to figure it out. Give me your best rock and roll yes or no. Let's see if you're right. Volume equals area of a side multiplied by the height. 120 cubic meters equals 40 times the height. 40, 80, 120. That's 3. The height of the room is 3 meters. If the banner is 2.5 meters tall, we'll totally be able to hang that bad boy. Thanks for working out some rockin' math with me today. We took what we knew about the volume of a rectangular prism and figured out the height of my practice space and determined it was tall enough to fit the new banner. We used a little multiplication, a little division, and a lot of sweet brain power. Well done.